It's week 36 of 2022. This is Talkin' Science, catching you up on the month's biggest stories with Dr. Brad Tucker, and they are dominated by Artemis and James Webb. As NASA engineers attempt to troubleshoot the fuel leak that's nixed 2 launch attempts in a week, we wait for word on the next attempt to get the Artemis program on track. And Hubble's successor makes 3 key exoplanet findings just months after coming online. An oceanic world, a sandy cloud-covered world, and the first direct image of yet another orbiting a distant star. Strap in, Dr. Brad's here to dissect it all.
This is Trekzone's Talkin' Science.
Yes, indeed it is. Your monthly reminder that Trekzone membership is available via the join button under each video on YouTube or via the trek.zone/support. Plus Trekzone's on Twitter, Facebook, Instagram, and your favourite podcast feed. Find us, like, follow, and subscribe. We now have super thanks enabled on the channel as well. It's the ability to contribute to us without becoming a member. Support us and make more great content. And if YouTube's not your thing, you can jump onto the trek.zone/PayPal to contribute to the 20th anniversary fund for July next year. Dr. Brad is here. He's on social media at btucker22 on Twitter, Dr. Brad Tucker on Facebook. Brad, an absolutely busy month. It is insane, everything going on in science and space right now.
Yeah, I mean, as you said, dominated by things like Artemis, and it's exciting to have all of those things coming to play. But you know, it's been an exciting time for every space enthusiast, and it's great that so many people, I think, have been enjoying it and excited, not just the kind of normal space enthusiasts.
Exactly right. Well, we have a very, very busy show. Normally, when I'm doing it by myself, we've got 7 stories. Today with you, we have 7 as well. So, very busy show. Let's kick it all off with MOXIE, the little science experiment on the Perseverance rover that's making massive leaps forward for sustained habitation on the red planet. It's made oxygen, Braz.
And this is kind of, and this is the amazing thing is that it has made so much oxygen. Now, MOXIE was the first instrument kind of deployed. Like, yes, they were all deployed on Perseverance, but it was really the first one to get going. And it was exciting when they made that first batch of oxygen. Now they've made 7 in different environments and different parameters and that sort of thing. And so it's really cool because what they're seeing now is this ability to convert carbon dioxide into breathable oxygen. And this is a really important step. If we're going to start living off the land on Mars, air is going to be one of those big things. And if you can create it from the stuff that's already there in a fairly quick way, now potentially you can go store bunches of oxygen ahead of time. So a really big game changer for future, hopefully, Mars exploration.
It absolutely is. And let's go around the sun now, because NASA's Parker Solar Probe has just flown by, making scientists, not the first time it's done it, but it's been the closest. Scientists are extraordinarily excited by its 8.5 million kilometre close shave around our star as she enters a period of solar maximum.
Yeah, this is the sort of thing, you know, we've been seeing a lot of activity now from the sun, getting into, as he said, that solar maximum for the next 3 years. And now that as Solar Parker Probe's going to start doing a lot of these orbits for the next years, hopefully, it can do one of the big goals, and that is checking out the solar weather. But if they can get, which is the hope, is to see in the area one of these solar storms erupting and that sort of thing, that would be a big game changer. So some really exciting things, I think, in store for the Solar Parker Probe and our sun.
Absolutely. Well, from things that are moving forward and doing wonderfully well to our big headline of the week. And of course, of the month, it is Artemis. There she is on the pad from that first attempt. She's failed to launch twice in a week, and it seems to all come down to one seal at one part of the core stage, the hydrogen quick disconnect interface, Brad.
Yeah, look, it's disappointing that they've had these problems already. You know, look, firstly, it's not a surprise they've had problems. This is the new launch of a new rocket. It's the sort of thing that happens. Everyone forgets NASA blew up an awful lot of rockets before the Saturn V worked, right?
It's
easy to have a short mind. But so this is the, I think, important thing. This is part of the process. And yes, it's disappointing, but I think it's disappointing because of how many people are interested. And that's in some ways a good thing. They will get it right. But as you said, they have a problem with the fuel line. The quick fix that they were hoping of essentially just filling up slowly didn't really work. They had an even bigger problem the second attempt. So now we wait for them to actually replace probably the seals and hopefully in the next month or so launch this rocket.
Now, there was talk for a few days that the team would have to roll the rocket back to the vehicle assembly building, carry out the repairs, roll it back out. But the engineers seem to have settled on a fix at the pad. A lot of infrastructure going in to secure the rocket itself from any sort of weather damages and things like that. So certainly some interesting things. They are going to have to roll it back to the pad to complete testing little bits and pieces and resetting some batteries and stuff like that. But it's looking like we might see the fruits of the labor on the pad very, very soon, Brad.
Yeah, and this is kind of the debate that they were talking about afterwards, that there's benefits of doing it on the pad versus rolling it back to the vehicle assembly building. And, both are going to take time. As you said, there's a problem with batteries and how long they can last out there, launching the range permissions. And one of the other kind of big issues that they run into is early October, the SpaceX Crew 5 mission is set to take off from essentially 39, the same pads, their neighbors. So they kind of have to get out of their way of that launch early October. And so that creates this very interesting time constraint that they have to work around.
Well, nothing has been easy about Artemis or the Space Launch System over its life. Is NASA having to persevere with a bad design, do you think, Brad?
Look, there's been a lot of talk on the design that's highlighted, from the fuel type they use to the reusability and those sorts of things. And, I think whether it is a bad design or not, I'm not going to say either way, in my opinion. They need to get it to work. It is hard. And they are actually the closest to getting to the moon. Let's just be clear here, right? They are. We talk about Starship, and it's going to be great, and it's going to make big success for SpaceX. They are years ahead of getting to the moon where other groups are. And so that is a big point. It's easy to forget about. Does it mean there could be design improvements? Sure, there could be design improvements for everything. That's part of the process. I think what the big thing it's going to do is to get the engineering and the technology and the systems in place to get to the moon. They're also doing longer durations around the moon. This is, everyone, I think, just thinks, hey, can't you just redesign Saturn V and roll it out? Well, no, it's a very different world. They're going for different missions, different purposes, different things. The Orion capsule can carry more. So there's all these little things that come into play, that it's not just simply as saying, hey, can they redo this or not? This is a new way of going back to the moon. And it's always hardest for the first person who does it.
It absolutely is. Let's move to what's next for Artemis. As you say, Crew Dragon is coming up. So we're looking around mid-October for the next launch window. NASA's website shows 34 windows from mid-October to December 23. So sometime in there, hopefully, we're launching, Brad.
Yeah, look, I think that's the plan, and it just depends on how quickly they can get it ready. And then, as he said, depending on their fixes, what testing they need to do, and on all those sorts of things. So it is involved. There is work that has to be done to get it all ready. They will get there. And that's the thing, is they will get there. It will launch. And then when Artemis 2 is getting ready to launch, everyone will forget about the 2 delays that they've had, right? We don't remember those delays. We remember the successes. And so I think this is important. And it's also because it is a test. It is good that they can find the problems, detect them, and come up with solutions. It's good when things are working. The challenges arise when things aren't working, and it happens a lot. So they've proven that they can do that as well. So I think there is a lot of positives. Yes, we would all love to see the rocket launch, and yes, it will be one day. This is part of the process, though.
Now, I know the Australian space industry is a little hesitant to have failures be broadcast. And I guess NASA would sort of be feeling the same way with Artemis as well. Not a very good look if the very first space launch system and Artemis blew up on the pad or just after launch. So finding these things before liftoff, and NASA's been quite forthright with safety comes first and aborting these much publicized events. Mainstream media all over it as well, but safety comes first, and we've got to sort out these fuel issues.
Well, and it's an important part of the process. I think it's very easy just to be blinded that things work. Well, they don't. It's hard. My car has died. We've been building cars for over 100 years.
Yeah.
Why did my car die? Because these things happen. They are complicated, parts wear, there's design flaws, stuff happens. And so
you're a bit of a lead foot as well.
Yeah. But to shield the reality of it, I don't think it helps. I think this is just being, as you said, it's being open and transparent. And that's all you could really ask, is that it happens. And no one wants to see the rocket blow up. You're correct. And it's important to talk about safety does matter. So do your checks. How often have you ever been on an airplane and they do a safety check and they have an engineering problem or stuff? All of these things arise in the everyday world that we live in. Space is no different. And in some ways, it's good to see that it's no different than the other things. It just happens so less compared to planes taking off. You pay attention to it, especially when so many people are anticipating it. You don't notice all those other flight delays. You just notice the one when you're waiting in the airport for 2 extra hours.
Unless you're flying on Qantas here in Australia.
Yeah, well, so then you notice everyone's, yes.
Exactly. Well, look, so once they solve this fuel leak issue, that is the hydrogen that is being ingested by the core stage. Once they solve that, it does have to go to the back to the VAB to reset those AA system batteries. I'm sure they're bigger than that. It also has to carry out some pressure tests on each umbilical interface as well. So there are those steps to ensure, and having Crew Dragonflight in the middle of all of this is probably a good thing for NASA.
Yeah, and you're right. I think this is part of the process. It is going to take time. So yeah, having some other things that are happening is good. We also have the DART mission happening at the end of the month as well. So lots of exciting things to look forward to. Yeah, was it a bit like we were told Christmas was coming and then someone said, oh, nope, kid ya, it's actually October. Yeah, but we do know Christmas will come, and so will the launch of Artemis.
Exactly. Christmas is always coming. I think that's the important thing. Now, as I said, NASA's been forthright with that safety. We don't have a crew on board Artemis 1. Probably a good thing. They'd be stuck on the pad for a little while. But everything is being treated just as seriously as if there was a crew in place, making sure all of these things are sorted for Artemis 2. We talked about it last month. There's not 10 missions before we're landing on the moon. There's only 2. And the third one, we're on the surface. So got to get these things right now.
Yeah, and this is, again, the difference is we've learned lessons from the Apollo era of what needs to happen and not. And that's right. They are sending people around the moon. That was Apollo 8 that they actually did it. And then, as you said, landing on the third one as opposed to Apollo 11. So a lot faster, a lot more steps involved in each step in learning. And so, a lot of stuff that flows on from what we've learned in the Apollo era to doing this, and then setting also the framework for the other groups. Again, we failed to think about what NASA does here means that it will probably be the framework for when Starship. They will first test to go around the moon before then they put people on it. This will be very similar to what other groups do as well.
Yeah, absolutely. Well, on to James Webb now, and Hubble's successor has measured carbon dioxide in an exoplanet's atmosphere for the very first time, Brad.
And this was a really important thing. One of the things that we failed, I think, is publicly in that first batch of JWST images was the measurement of the exoplanet atmosphere. They measured WASP-76b, which showed a lot of water, and it was this kind of steamy planet. And this was always one of the big science goals, was to measure exoplanet atmospheres. And now, as you said, with WASP-39b, a different planet, they've been able to detect carbon dioxide. Now, carbon dioxide is very important. We were just talking about in the highlights, converting Martian carbon dioxide into oxygen. Venus has a lot of carbon dioxide as well. Earth has some. It's quite common in some of the Earth rocky-like planets in our solar system. and having that kind of first big detection in another system outside of our own solar system is a really important thing. This is going to be a really cool step and a really important step that in our understanding of planetary systems, exoplanets, and down the road, what that means for habitability.
Well, transmission spectroscopy was the method of choice to identify the elements present in the atmosphere. Talk us through that process, Brad.
You're essentially looking at light coming through the atmosphere of the star. And so what you look at is you can measure the light of the star and then the atmosphere of the planet. Sorry, I should have said the light coming through the atmosphere of the planet from that star. And so you can kind of subtract the two. You take a measurement of what the elements are in the star, what the elements you see of the light coming through that planet due to that star, subtract the two, and what's left is from the exoplanet. And this has been done a few times. This isn't a new technique that JWST has invented. This has been around, but it's a very hard technique because you need to be able to precisely break up the colors of light for a very small thing very accurately. And so when James Webb was built, by looking in the infrared and with a bigger mirror in space, it can do it in a way that we previously haven't been able to do before. And so it's a really cool, exciting technique. One that, as you said, we've already that was the second planet, and now there's heaps more lined up already by JWST to start doing this. We've moved from the past decade or two just realizing how many planets are out there, now to starting to realize what are those planets like in terms of their atmospheres. And that's a big deal. Just to put this in a scale, if you were to look at our solar system from afar, Venus, Earth, and Mars, from the previous methods we've been doing, would kind of actually be categorized the same. We're all in the habitable zone. Some are on the border, or some are in the middle. We're roughly the same size. Venus and Earth are almost very close. Mars is a bit smaller. So you would kind of think maybe there's 3 Earth-like planets. What makes us different, one of the big things, is the atmosphere. And that's that step that JWST is taking.
And the release of this data is part of the early release science program. Webb has also suffered its own set of delays, which we covered on Talkin' Science before launch. So this is a nice way to get instant feedback on the success of the scope, isn't it, Brad?
It is, and they're just chugging through the results of this. And I think this is why so many of us were excited. It was benefiting so many different areas of science. We saw the deep images of galaxies. We're seeing galaxies images turned out. We found supernova already with JWST, images of Jupiter, exoplanets. And this is why we've all been excited, is it was going to benefit so many different areas of astrophysics. And it's proving in 3 months kind of operation now to be delivering the goods.
Now, this one's cool. Webb has snapped its first images of an exoplanet. These are actual images. It's kind of covered by all of the graphics there, but it will be up. This one is very, very cool. A direct image of an exoplanet, Brad.
Exactly. So, when you think about what we know about exoplanets, we find them either from the planet moving in front of the star, and we look at the dip of the light, the transit method, a similar way, but then we can measure the atmosphere of the planet, or a few other techniques. A lot of them are based on the measurements of the properties of the planet without seeing the planet itself. And here you're starting to see the first images. This is directly of the planet. That light is of the star, marked as the star, bouncing off the planet, shining it up, and us being able to see it. Just as people thousands of years ago would go out to the nighttime sky and see objects in the sky that move differently from the other stars, and those were the planets. Just as you can go out tonight and see Jupiter and Saturn and Venus in the nighttime sky, this is how we're seeing it now for the first time around a solar system way beyond our own scale. And this is another one of those big steps that JWST has done. The direct detection is a very powerful tool. Again, it's very hard. We need a really big telescope with very good imaging and the colors of light to see it. It's been hard from the ground. We have done this again on the ground. All of these techniques, the atmosphere and this, have been done previously on Earth. It's just so much easier and better with JWST.
That leads into my next question. We as humanity have a folder of just 20 direct images of exoplanets, but they're lacking that key detail, as you say, being snapped from the ground. I believe this is the first time we've seen one from a space telescope.
It is, and not the last. I mean, there's a heap of these that are in the pipeline to start imaging. And so this is kind of the exciting thing where we find ourselves in the decade of exoplanets. And it's just an interesting topic because the very first planet was discovered 30 years ago, 1992. The first planet around another star was detected. So in 30 years, we've gone from not even knowing another planet existed in another star to seeing a few, to with Kepler saying, hey, they're common, to test, realizing there are just so many out there, to now measuring the details of these planets. This is what the next decade is about. JWST and new instruments being built on the ground, measuring the properties of these stars, telescopes in ESO and at VLT in Chile, instruments now at Siding Spring in Australia are all into this world of measuring the properties and details of these planets. And so we'll go from putting a picture together of just how many planets are out there to what are all these planets like relative to our solar system, and the atmospheres, the gases, the sizes, the temperatures, the compositions, all these really big questions, really putting that bigger picture together of what these planetary systems are like.
And researchers discovered James Webb was 10 times better than estimated at getting these shots, these direct images. That's also a nice surprise as well, isn't it, Brad?
Yeah, that's the thing. Is like, it's one of those things, you build the mission for a certain spec, and when the quality is better, and this has been across the board, even with the first supernova that has been found from friends of mine in Baltimore, it was, hey, we didn't expect it this good and this quick. So JWST is delivering beyond what we imagined. And so that's the exciting thing. It's transforming it even more than what we thought it'd be transformed by. And we thought that was a lot.
Well, the telescope is in such high demand that these images are going to be likely be a bit of a treat rather than everyday occurrence, really, though, aren't they, Brad?
Yeah, and this is the thing. There are so many different projects that are on board. Telescopes are measured by how subscription rate, what we say. So for how many hours are available, how many hours are asked. For Hubble, that's like 10 to 15 times. So for every hour on Hubble, there's 10 to 15 times worth of asking. The next call for James Webb Space Telescope, so they go every year, is just about to come out. So we'll all be spending our time writing our ideas, going through a panel, and then being vetted. You can imagine that it will be dramatically more than that now that people are seeing, hey, the data is here, it's coming through. And this is already with all the programs already approved. So it's going to be a lot. And this is the exciting thing, is we have decades, hopefully, worth of these discoveries to be made.
Looking forward to it. Another planet of interest, VHS 1256-1257b, has shown us it has a sandy atmosphere, Brad. This is a brown dwarf.
Yeah, this is the cool thing. So brown dwarfs are these ultra cool stars. They're not stars in the normal sense if you think of our sun, but they are a star, but they're very cold. And, maybe straddle the boundary between Jupiter-like things and our sun. And so we know they're very cold, but they have interesting gases and atmospheres. And so, as you said, for the first time in this brown dwarf, they've detected not cloud system. Cloud systems are not a new thing. We've detected it, but these bands, almost more akin to Jupiter, but bands of essentially sand, this fine cosmic dust, silicates, as we say, building blocks often for planets that come together to actually form a sandstorm on the planet.
Now, we have the best spectrum analysis yet for a planetary mass object, allowing us to not only better understand these so-called failed stars, brown dwarfs, but it represents just a sample of what James Webb can provide us. The atmosphere has a reddish hue, thanks to that greater detail. We know that. The spectrograph also tells us that water, methane, carbon monoxide, carbon dioxide, sodium, and potassium are all present, along with these silicate particles as well. Very fascinating stuff to be able to analyze all of this without actually putting eyeballs on it, Brad.
This is the cool thing, right? Is that you're able to see all of this detail of the composition, the cloud systems, almost the weather from afar. And this is, why, again, we become so excited about these possibilities, because of the way it can transform. that entire picture together of a planet, just as it's doing for all these other fields. And as you said, it's amazing to start thinking about putting the picture together without seeing it. And we're further in advance of what we are with studying exoplanets and where we were with our planets in our own solar system decades ago, before we started sending probes and things like out there. So it's a really exciting time to be able to do and see these results.
The James Webb Space Telescope hasn't even been online for 3 months, and we've already filled a whole show with a sample of her data. Just incredible, Brad.
It is, and I think that's kind of why I like putting all these stories together, because they are just rolling off. You can't just choose one of those. They're all so cool and yet also different, and that again goes to the power of James Webb benefiting all these different areas of science well beyond what we are even expecting. So to think of the decades that we're going to start seeing of all the results starting to come out is just simply gobsmacking.
It absolutely is, Brad. It is great to pick apart the past few weeks with you. We're going to do it all again next month, and hopefully sooner than that for another Artemis live stream. Thanks for being here.
Fingers crossed.